The elements have been classified or grouped in the modern periodic table as per the groups and the periods. Now in the modern periodic table you will find there are 4 different regions or 4 different blocks, spdf, and the elements have been kept under these blocks. Okay, so today we will be understanding what is spdf, which elements will fall in the block and how to distinguish them, how will we know which element comes under S or P or D or F block, and also we will be doing what are the characteristics of a modern periodic table. For the first part we shall be discussing the SPDF block. Now when we look at the modern periodic table, see here, when we look at the modern periodic table, we see that there are certain areas 1A and 2A. This has been kept as S block. This part of the modern periodic table is the S block. 3, 4, 5, 6, 7 and 8, these groups are kept from 3 to 8. This is the P block. Between the S block and the P block is the D block, and below the modern periodic table there are 2 rows, which is the lanthanide and the actinide. This is your S, P, D and F block. Okay, so that means our modern periodic table, it is made up of 4 blocks: S block, P block, D block and F block. Now how will we know or how will we remember which elements comes under S or P or D or F block? We shall read it here. Remember when we did electronic configuration using the subshells, yes, we saw that according to the Aufbau principle, the subshells have an increasing energy. Lowest energy subshell are filled first, and then we go on to filling the next level of energy, right? So now let us see which elements comes in the S block. S block are 1 and 2A group. 1A and 2A group is known as S block, and in this S block what happens, which elements are there? Elements having valence electron which are filled in the S subshell. What is S block? 1A and 2A groups are known as the S block, and in this S block which elements are there? Elements having the valence electron. Valence electron are the electron which is present in the outermost shell. So if these electrons are filled in the S subshell, then the elements comes under the S block. Now all these elements, the property of the elements in the S block, these are electropositive. Electropositive means they readily give away one valence electron to fulfill the octet or the duplet state, and while giving away the electron they become an positive ion, electropositive. They gain the charge of a positive ion. Example of elements in S block. Let us look again at the example of elements. See here. Hydrogen, lithium, beryllium, sodium, magnesium, potassium and calcium. Let us take till calcium only. Okay, so out of this I will take the example of sodium. Sodium example, here you can see example sodium. For better understanding, sodium has 11 electrons. I'll put it here. Sodium has 11 electrons. When we arrange these electrons in the subshell, it becomes 1s2, 2s2, 2p6, 3s1. So look at the valence electron. It is there in the S subshell. So this element comes under the S block. Another element that will take, which is in the S block, is K. K has 19 electrons. So 19 electrons will get distributed: 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Again the valence electron, outermost electron, is there in the S subshell. So again it comes under S block. Likewise, we will see there are, after the S block comes the P block. P block, same thing like S block. Now which area of the modern periodic table is the P block? The areas, the groups from 3A to 7A. 3A, 4A, 5A, 6A, 7A and 0 group, which are having the valence electron in the P subshell, these elements comes under the P block. Example, what are the characteristics of the elements which comes under the P block? These elements, some are metals, some are metalloids, and most of them are, some are metals, some are non-metals, and most of them are metalloids. Example of P block for better understanding. Let us take any element which lies under that block. Example, we shall see aluminium. Let us see in the P block. See here, this is the P block. If we take aluminium, aluminium has the number 13. So 13, when we arrange it according to the electronic configuration of the subshell, we shall have 1s2, 2s2, 2p6, 3s2, and the valence electron it is in the P subshell. So that is why this element it lies in the P block. Likewise, any element, for example, you can take any element. If you take after aluminum comes silicon. When you take the example of silicon, you will see when you arrange it the electronic configuration, you will see that the valence electron of silicon will also again come in the P block. Okay, so these elements have been arranged under the P block. That section is known as the P block. Okay, so my next video will be talking about the D block and the F block.